There we go. This webinar is being recorded. Good afternoon, everybody. Great to see you all again. My name is Adrian Kosmaczewski, and welcome to the Cloud Native Computing Switzerland Meetup, the third meetup of 2021. Today, it's October 21st, 2021. It's 4 p.m. in Zurich, where we are greeting you today from the beautiful city of Zurich, and it's sunny for a change. So basically today we've got an absolutely terrific event for you. We have, well, this welcome and intro that I'm doing right now. Wouter Dullaert from Exoscale is going to talk about continuous delivery made easy with ArgoCD. Then Steven from Noname Security is going to make us understand the security risk associated with APIs and how to tackle them. And finally, Simone Pomata from AWS is going to talk about the AWS load balancer controller this afternoon as well. And then some final words, and around 6 p.m., 6:05 p.m., you will be free to go back to your usual life. Just a quick reminder, we are recording this this session, this meetup, and we are going to make that video available for you on vision.tv. So please be sure to, the usual subscribe, like, and share, and make sure to hit the little bell so you get reminders, because we post new content very often there. During this session, all the people attending this webinar basically are able to interact primarily through the Q&A box. So there's a little Q&A box that you can see at the bottom of your screen. And you can post there any kind of questions, excuse me, and the panelists are going to try to answer them. And of course, there's also the possibility, if you would like to talk to the speakers, there's a raise hand functionality that I will be watching on the list of participants, okay? So that at the end of the session, so please let each one of the speakers show whatever it is that they have to show. At the end, if you would like to ask a question that is probably a bit too complex to write down, a bit too long to explain, and it fits, of course, if it fits in the time box of these sessions, please feel free to raise your hand. I'm going to allow you to talk, so you will be able to use your microphone to interact with the speaker. If your question is a bit too long, I will ask you to wait until the end of the 3 sessions so that those who would like can stay and maybe ask further questions to our speaker. So feel free to do that. But of course, all we ask you is that you please respect the time slot so that all the speakers have the opportunity to basically speak their minds. Of course, all of that goes without saying. Please abide by the conference code of conduct that you find on vision.ch in our website. Basically, be kind to everyone. That's the basic rule. That's all we ask for. We've got future editions already planned for this Cloud Native Meetup. First of all, we have one in February. And this is the big news for today. We are planning to do this in person, once again, back again with, the usual beers and pizza. So that's basically going back to how it used to be before this whole situation started. And we already have one speaker who signed up for this session, but there are still 2 slots. So feel free to let us know if you will be available. Another one is in May 19 next year. All speaking slots are available for that one. If you would like to present, or you would like to host the CNC meetup in your company, in your offices, we would be very glad to know about it. Please fill the form at cnc-meetup.ch and let us know. Please follow us. Of course, the most important is the vision.tv on YouTube, and you can follow us in all of these social networks, and of course on GitHub, because there's a lot of open source code that we are sharing. But enough of me, because you didn't come here to listen to me. You came here to listen to our awesome speakers. So let's go now to Wouter Dullaert from Exoscale, who will talk about ArgoCD. So Wouter, the stage is yours.
Hi, so my name is Wouter Dullaert. I'm a team lead at Exoscale, which is a Swiss cloud computing company. And the reason I can speak to you now is actually because it's virtual, because I'm talking to you from Belgium. And let me actually try to share my screen over here. Let's do desktop, because we're going to be switching context quite a bit. There we go. This is in the way. There we are. And then I need to click slideshow, I think. There we go. So I'm going to talk to you today about continuous delivery and how we can make that easy using cloud native software. And so the first 10 minutes of my talk, I'm just going to talk a bit about continuous delivery, what it is, why we want it. And then the majority of my talk will actually be a long demo where I'm going to try to show some of the concepts using ArgoCD. So all that said, what is continuous delivery? So what are we talking about here? And so this is a quote I've stolen from Wikipedia. So Wikipedia defines continuous delivery as a software engineering approach in which teams produce software in short cycles and then ensuring that the software can be reliably released at any given point in time. And then when releasing the software without doing so manually. So the last part there for me, the fact that we want to deploy our software automated is kind of implied by the fact that we want to be able to do it reliably. But let's kind of continue there. So now that we kind of know what it is, why would we want to practice continuous delivery? So the first main benefit is that you got a much faster time to value. Like the quicker you can get your software in the hands of your customer, the quicker it can actually start providing value for your customers and hopefully make money for your company, which is a very attractive premise. The second one is related in the sense that it allows for shorter feedback cycles. So the quicker we can get our software out there, the quicker we can actually get feedback on whether it's working correctly or what it could be doing better. And so essentially short feedback cycles are really good to get to a good result much faster. And then the last part, which can be slightly counterintuitive, is that the faster we can deploy changes, actually the less risky our changes become, because invariably our changes are going to become smaller. And as they become, when they become smaller and we deploy them into production, they're just less likely to cause issues because you're only touching a small piece of the entire system. And then secondly, if things do go wrong, you only have a small change to revert, and you also have a much smaller box to go look for where the problem was. So essentially deploying small changes very regularly is a much less risky approach than deploying large changes every so often. And so, right. So so how can we then actually practice this continuous delivery thing? So the really high level goal of this entire process is essentially to eliminate the fear of change, right? Like how do you get good at something is basically by doing it often, right? So the more that you can deploy a change, like the more it becomes effectively a non-event, right? Like we've done it so often, it always works, so it's always fine. So we want to eliminate that fear of changing something. And so in order to do that, like we need to essentially find the problems before we ship the software, right? So this means we need to have good testing, and good reliable testing, essentially. The second part is like we want to create a fast and reliable deployment process. And this kind of implies that it needs to be automated, because whenever a human has to touch a keyboard, he's going to make a typo and things are going to go wrong. So this should be automated and quick. Then we want to start working in small batches. And then the final part is just as important. Like you want to evolve a system that lets you rapidly detect, fix, and learn from production incidents. And so this means that having good observability in production and knowing how your systems are doing is kind of integral to this whole approach. because like you can ship your changes quickly if you actually can't measure how that affects your production system. You don't really know whether you're doing well or not. Now, obviously, these are a lot of different items, and if I have to cover them all, I'm going to need a lot more than the 40 minutes that I have for this talk. So basically, I'm going to focus on the first two items over here. So I'm mainly going to talk about how you can leverage cloud native software to create a fast and reliable deployment process. And I'm going to touch lightly on some approaches on how you can how you can do particular kind of testing before you ship your software. And so to sort of like wrap this up with a quote from the person who essentially wrote the book on this, Jas Humble, which is like, continuous delivery is about making it safe to ship your code into production. And safe is doing a lot of work in this sentence. So it means that it needs to be safe from a technical perspective, but it also kind of like needs to be safe from an organizational perspective. So something that I kind of do want to highlight is that continuous delivery is really a process, and you sort of need all the components for it to work. And it's not just necessarily about tools, right? Like tools very much can help us to get to continuous delivery, but they're not the be all end all of this. You know, like just like using Jira doesn't make you agile, using any of the tools that I'm going to show doesn't, you know, make you do continuous delivery. And the flip side is actually also true. Like you don't have to use the tools that I'm going to talk about to practice continuous delivery. Like these tools, they're very much focused on a cloud native environment. If you happen to be building games for mobile, they're probably a lot less applicable, but that doesn't prevent you from doing continuous delivery. Like you will just have to set up your process in a different way. And so like an analogy that I kind of like for this is like you have to basically swap out life for your system or software in this analogy, right? But it's kind of like our systems, they rely on a dynamic balance, right? Like they need to be moving forward in order to be stable. Like if they're standing still, a small change in the outside environment will make them fall over. So you need to have like a steady pace moving forward for the system to be stable, but also for you to be able to course correct, to be able to go left or to be able to go right. So it's very much kind of like riding a bicycle. If you're just trying to stay stationary with a bicycle, you're eventually going to fall over. All right, so now that I've kind of talked that it's not about tools for a bit, let's talk about tools. So I'm first going to quickly like show the platform on which we're going to be deploying our software. I'm not going to spend much time on these, sort of like assuming that they are there. And so for each of the components, I'll just sort of like quickly explain what they do and then skip over them so that we can get to the ArgoC part. So the first thing is like I'm going to assume that we're deploying to Kubernetes, and we're going to be using a managed offering for this. In this case, the SKS offering from Exoscale. And so also for the rest of the talk, I'm kind of going to assume that everybody has at least a baseline understanding of Kubernetes and some of its jargon. So I'm going to assume that you know what a pod is, what an ingress is, what a service is. Right. So in order to like make it really exciting, I'm also going to create all of this infrastructure from scratch during the talk and challenge the demo gods. So let's start by creating our Kubernetes cluster over here. So I hope the screen neatly transitioned into my terminal. And I have a nice Terraform environment over here. I'm just quickly going to show the SKS cluster. So like I said, not going to spend a whole lot of time here. So essentially what this is doing, it's creating a Kubernetes cluster, and it's going to be setting some security group roles so that we can use it. And then we're going to basically add some compute nodes to it so that there's something to run our software on. Oh, this is not a QWERTY keyboard. So first thing off, Terraform init, because I need to install the, I think it's called upgrade, right? There we go. because I need to install the Exoscale provider. Then we're going to do Terraform plan and just check what it's going to do. And so we can kind of see that, right, this is creating my security group. It's creating some rules in there. It's creating my cluster. And it's creating some nodes. And so we're going to do Terraform apply. Off we go. And this will shoot a cluster into my account. Now, one of the benefits of using like a managed offering here is that this creates kind of fast. So this will not take longer than 2 minutes to provision, including the compute nodes. And this is really nice because it means that you can actually create throwaway clusters. So imagine you have a bunch of software that relies on some Kubernetes primitives that you really want to test. You can use this to create a one-off cluster for a single integration test run. So you can create a cluster from scratch with a known good state, deploy your software into it, run your integration tests, and scratch the entire cluster at the end of it without having to break a sweat. And that's like a very powerful thing, because typically if you try to reuse a deployment environment to test your software into, like eventually it's going to kind of get corrupted, right? Like some tests are going to leave some state inside of the cluster, which then affects the subsequent tests that you're running in there. And like you get false positives, you get false negatives, like you end up with a massive script to sort of clean this. Or you end up with, I don't know, a schedule where teams can take turns using the environment, whatever. So using basically ad hoc cloud infrastructure for this is really nice. And so like to use this, and so you can see like it took like 1 minute 37 seconds for me to get a cluster, including my compute nodes. I've sort of put a small snippet of code here. So this will produce me a kubectl file. Hold on. kubectl.yaml. So we're going to shoot that here. Very well. Seems like I'm using an outdated version of our CLI there, or I need to update my stuff. And then the last thing I'm going to do is it's like a small trick. We're basically going to set the kubeconfig variable to the kubeconfig file over here, and that means I can use kubectl from everywhere I am, and it will point to my cluster. And then get nodes just to show that this is a real thing. Boop, there we go. They're not ready yet, but they will be in a second, hopefully. Didn't install watch. We're just going to go try that again. And they're ready now. So I've got a working Kubernetes cluster. I've got 3 nodes. So that's really awesome. Oh, we're going to go back. So the following part is Let's Encrypt. So Let's Encrypt is a really nice service provider that allows you to get ad hoc HTTPS TLS certificates, essentially, which I'm going to be using to protect the URLs that I'm going to create for this demo. I've got some manifests for that in the Kubernetes folder over here, more specifically in Lego. So if I quickly go in there, I've created a small program which runs as a cron job and essentially requests a certificate from Let's Encrypt using the DNS challenge. And it will, the reason it's a cron job is because like it will daily check whether the certificate is close to expiring. If it's close to expiring, it will renew it. So that's that. Here's one place where I'm going to cheat a tiny little bit. So first I'm going to make the namespace that this is going to live in, which basically creates a traffic namespace. And then I'm just going to provision the secret.yaml here, because Let's Encrypt has very tight rate limits. And so I was kind of scared to bump into the rate limits when building my demo. So I've basically saved my secret and it's already there. So I'm just going to shoot secret.yaml in here. Nope. That's the wrong namespace, actually. So we're going to delete that. Again, because I need to tell it to use the right namespace, which is traffic. Oh, and set this to apply. Cool. So essentially, I've now have a wildcard certificate inside of my cluster that I can use to protect URLs with for the various applications that I'm going to deploy. Nice thing about a wildcard certificate is I don't really have to care. Like I can use any number of domain names and the certificate will protect them. And this is a bit of a theme. So if we then go next, I'm going to use a tool called external DNS. And so let's go for external DNS, or let's just go to folder up. Let's actually show. So this here is, it's a small controller that's going to run, and it's going to look at ingress manifests. And for each of the hosts that it finds in the ingress manifests, it's going to try to provision the necessary DNS records for it, so that they point at the load balancer that is responsible for the ingress record. You can set various filters so that you don't try to register DNS entries for domains that you don't own. But the nice thing about this is that if you are a developer that's using this platform, you don't really have to worry about DNS. All you have to do is give an ingress document and sort of declare, like, I want some traffic to be routed on this host name, and external DNS will make sure that the world has, you know, the right shape for that to work. So it just takes like a problem away. As a dev using this platform, I don't have to worry about DNS. I just ask for my traffic to be routed on a host name, and magically in the back, stuff like external DNS makes it so. So we're going to be, again, apply-f. First, we're going to create the namespace. And then I'm going to kubectl in that namespace, external DNS apply-f, external DNS. Cool. So there's like a bunch of YAML that's going in there. So it's also like one of the benefits from using Kubernetes is that things are idempotent. I can apply the same manifests as often as I want. It'll just tell me that nothing has changed if I do it twice. So again, this is part of making it robust to deploy software. And then the last piece of my platform is traffic. So this is essentially a load balancer, and it's going to make sure that network communication from outside of my cluster can reach stuff inside my cluster. And it's going to also do this at properly TLS protected endpoints. So that's the last one. So I'm not going to spend much time on it because we've got a talk coming up that's going to talk about ingress controllers. And so I think I've called it ingress. Nope. Apply-f. What did I did call it ingress? There we go. So again, this doesn't create a whole bunch of different things. It basically creates a traffic service, and it creates a traffic deployment. So this is the actual load balancer, and then the service is necessary. So maybe I will show the service real quick because I'm playing a small trick there. So if we look at traffic and we look for the service. There, nope. Where is it? Just gonna scroll through. There we go. There's more. Sorry. So the nice part over here is I've asked for this to be of type load balancer, and what that means is that the Kubernetes cluster, which contains a specific Exoscale component, will provision me a load balancer that's going to front this particular service. And so the entry point into our cluster is going to look, the request is going to hit the Exoscale load balancer, which is then going to talk to traffic, and then traffic knows how to route the request into the necessary pod in the cluster. So that's this guy. So now that I have this, I've got like a basic deployment platform, right? So we've got Kubernetes. You can use all of Kubernetes. I've got TLS provisioning. I've got DNS provisioning, and I have a load balancer that can, route traffic to whatever service that I want to run inside. And so this is kind of why I sort of like this, is because there's a whole bunch of things that have been taken care of for you. And also one of the things that I've tried to do here is make sure that the easy path is kind of like the secure path and the right path, which is why, for example, like traffic will take care of routing HTTP traffic to HTTPS, and why the Let's Encrypt piece is there. So a developer using this platform doesn't have to worry about that. If they just use it and they use the defaults, they get a secure environment. And then the last thing, and so this is going to be the start of the show, is ArgoCD. I'm not sure how I'm doing on time. Let me see, I still have a bit. So right, so the last part is ArgoCD. So let me first try to sketch out what ArgoCD is doing. So ArgoCD is it's a continuous deployment tool. And so what it tries to make sure is that the state inside of the cluster always reflects the state as requested by a Git repository. So in very simple terms, this means that you basically check in your Kubernetes YAML files into a Git repo, and then you tell ArgoCD to watch that repo, and ArgoCD will make sure that those manifests are always applied on the cluster. So if you change anything in Git, ArgoCD will notice this, and it will apply the changes onto the cluster. And why is this powerful? Because Git is version controlled, right? And so it gives us an audit log of what is happening in our environment for free. Like, we can see what changes have been done at which point in time. We can roll back history if necessary to go back to a previous point in time. And then the last part here is that there's extremely good tooling around working with Git. Like, we've got services like GitLab and GitHub, which make it very easy to collaborate on all of these manifests in a collaborative way, using Git as sort of the mechanism for managing changes. So it means that all of our processes and habits that we have writing software, we can transpose onto like writing our deployment manifests. And we don't really have to worry about how we ship that to the cluster, because that's what ArgoCD is going to be doing for us. So if I go back in true cooking show style, here's one I prepared earlier. I'm going to, you can see the ArgoCD folder, so I'm going to apply ArgoCD onto the cluster. In this case, it's using customize, because the upstream ArgoCD team makes customized managed manifests available, and they're of very good quality, so I'm reusing them, and I've just tweaked them a tiny little bit so that they're usable for the demo. So we're going to be doing customize argo build ArgoCD / I think. So what you'll see here is, like, if I do it right, that will produce a ton of YAML onto standard out. Before you do this, like, do check the manifests, right? But I've done this previously, so I don't really skip that one. And then we're gonna apply this in our cluster. And so kubectl apply -f- allows you to take input from standard in, essentially. So this is doing the same thing. It's building my YAML manifests, and then it's shooting this into kubectl, and it's provisioning it in the cluster. Boom, 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 boom. All right, there we go. And now I have to wait a few seconds for DNS to propagate. But if all goes well, this means that I should be able to get argocd.sks demo.mydomain.com, and it's not yet there. So let's see, dig on this one. Yeah. Just to see, it's not yet there. That's I challenged the demo gods a bit too much, it seems. And also the problem is always DNS. So we're gonna have to wait for, this might be annoying. It's already there, but of course it's not yet here. This is annoying because now I've got it cached. Okay. So can you do that here? Maybe I actually can. So let's just fake it then for a minute. Let's get the host name and make our machine aware of this. Let's see if that works. Could possibly go wrong, and it works. There we go. So I've got my freshly installed ArgoCD instance over here. So I'm kind of going to walk you through some of the features of it and just show like tiny bits and pieces that I hope you can use to build a decent continuous delivery process that fits your needs. So initially, we're going to start by creating an application. And I'm just going to do it manually from the UI. And so we're going to call this application demo. We're going to put it in the default project. So projects are a way to group various applications together and also to do like access control. So you can make sure that certain projects can't touch other things. But in this case, we just have the one and everybody has access to all of the cluster. Gonna set the sync policy to manual just because that helps a bit. We're gonna tell it to auto create the namespace if it doesn't exist. And then we have to tell it what it needs to provision. So we're gonna look at something on GitHub, Exoscale SKS ArgoCD.git, I think. There we go. It should find this, and then it should also, so it has in the back already queried my URL and found the various projects that exist there. And so we're gonna point it at demo. So you don't have to have like one application per Git repository. You can have multiple ones and just watch a certain path there. Yeah, that's really it. So I need to give it the cluster. We're gonna deploy in our local cluster. We're gonna deploy in the demo namespace because I'm not very creative right here. We're gonna say create. All right, boom. So now I have an app. And when we look at it, it has taken a look at, and maybe I should just show this, right? So the Exoscale ArgoCD. So this is a public repo that I've made, which just contains a bunch of manifests. Basically contains all my demo code from this talk. And so it's watching this folder over here, right? So we've pointed it at this folder, which contains customization.yaml, and then a demo.yaml, which contains these manifests. So it contains a deployment, it contains a service, and it contains an ingress. You know, like your standard HTTP service stuff on a Kubernetes cluster. Come on. I want to swap. All right, there we go. So ArgoCD is watching that. It has found all these resources like, hey, a service should exist, a deployment should exist, and an ingress should exist. And then it's kind of telling us like, well, I'm not finding it in the cluster. You can click the app diff button and we'll tell you like, currently you've got nothing, right? But I want to have these. So that's fine. You've actually taken a look at this. This looks okay. And then you just sort of hit the sync button. And there we go. We wait a bit and all of the resources are being created inside of the cluster. So we're gonna wait for the container to spawn. And it even looks at health checks. So if you've got a health check defined on your pod, like, you know, it'll know the icons will change, whatever. And so I've also created an ingress over here. And so our app should be available on app.sksdemo.mydomain.com. So I'm gonna wait 5 more seconds because this time I sort of want the DNS to work right off the bat. But if all goes well, if I go there, we should see the app. So sksdemo.com, please work. And there we are. That's my Nginx. That's the app that I've discovered that I wanted it to do. And it's been deployed and it's useful. You can reach it. So that's that. Now, obviously, initially, you sort of want to do this manually because like you're debugging your manifests. And so you don't want to hit all of your problems to hit your environment. But after a while, you know, like the environment, it's stable, you know, that manifests are fine. We know that these work and like the changes are not that big. Like typically you're just bumping the image because you just want to deploy a new version. So something that we can now do is then over here, enable auto sync. And what this means is that if we update our manifests on Git, ArgoCD is gonna see those changes and immediately apply them onto the cluster. So for the purpose of this demo, we're sort of gonna do that. And then there's a few additional options over here. So you can also sort of say self-heal, which is currently disabled. But what that does is if somebody actually messes with the resources on the cluster and ArgoCD sees it, it will roll that back. So you can do it like, so there's 2 directions. You can say like, okay, always apply stuff from Git into the cluster, but you could also sort of say like, also make sure that nobody can change the cluster without changing Git, basically. And what the right setting is obviously sort of depends a bit on your application. So I'm gonna go on my demo folder here, and to show that that works, I'm gonna update my demo. There we are. I'm gonna remove this from comments like this, and then I'm gonna comment out this guy and this guy, right? So essentially I'm changing the app that we're gonna be deploying over here. There we are, git status, git add demo. We're just gonna say like update demo app. There we are. Cool. So anything else? No, that's fine. And we're just gonna push that straight into master because that's how we live in demos. All right, and if I'm quick enough now, it checks Git regularly, but I'm gonna give it a small push by saying, okay, refresh right now. So you can see auto sync, and it's already applying my change onto the cluster. We're gonna wait a few seconds, cool. And then if I actually go over here, and I probably need to properly refresh this, is it Command R on the Mac these days? There we go. This is my other app. So this is the Who Am I app, which basically, it's kind of like an HTTP echo. So it bounces back the HTTP request that I've given it. So just by making the small change into Git and pushing that to my repo, all of that went straight through to my environment. I am kind of running out of time. I'm seeing, so I'm going to skip a demo halfway through because I was kind of going to show that these applications, they are actually also Kubernetes resources. So what I can do here is kubectl namespace ArgoCD get applications, and it'll show you that, hey, I have a demo application, and that application is actually a piece of YAML. And that creates like a whole bunch of interesting stuff because it means that I can actually create an application which creates applications. And so it means that you can manage your ArgoCD setup through Git, because you can just do changes on Git on which applications you actually want to have provisioned inside of your cluster. And manage everything with the same workflow. But I'm going to skip the demo part of that because I've got only 5 minutes left. And I'm going to go to this application set thing, which is admittedly very alpha software, but it has some really cool features. So this is an extra controller that I need to install. So I'm going to customize build application set. Application set. Let's first dry run this. And a ton of YAML. kubectl apply -f from up. So we're going to set the application set controller. Cool. And so what an application set is it's essentially a meta ArgoCD application. So think of it like it's kind of to an application as a replication set is to a pod, if you know Kubernetes stuff. So if I go here in my applications folder, I have a demo PR application set there, which I'm going to show. And so this is kind of like what that application set looks like. And so it basically contains a generator. And so a generator will generate a list of values, and then it contains a template. And so the template is an application, right? And so for each item in the list that the generator makes, it will create an application with, using the template that you've given. And so one of the really nice generators that they recently added, which I'm a big fan of, is the pull request generator. And so you can point it at a Git repo and say, for each pull request that you have, create an application in my cluster. And so what I'm doing here is I've got my pull request. I'm saying like, okay, look at GitHub. So it supports GitHub and GitLab, which is likely to cover the majority of people. In this organization at this repo. So that's again my demo repo there, right? And my repo is public, so this will all work, but you can give tokens and like properly secure this if you want. So for each pull request on that repo, right, make me a demo app with the name demo branch number that looks at this particular repository, at this path, at this revision, okay, and deploy it in the demo namespace. Just to round this out, I've kind of prepared a pull request over here. So I've got a pull request which makes a few changes on my app, and we should see that appear in a minute. So what we're gonna do is we're gonna, in the ArgoCD namespace, apply my demo PR-f demo PR YAML. And that created my application set. And so my application set is now checking Git. And actually what it's done here, you can see it's created a new app for my application. Unfortunately, I don't think it's actually watching the right. So if I look here, and what I've done, it's actually is looking at it. So what I've actually done is I've configured this guy to be auto sync. So if we look at my pull request, I'm going to show it from the pull request. So the thing that I've changed is not actually changed much, but like the thing that I've changed is actually the domain on which the app is going to be available. And so it's made me demo app normally add pull request dot SKS demo mydomain.com.
So Wouter, we are reaching the end of your session.
And that's it. So
right on time.
Exactly. So you can see that I've got my app so you can now inspect the changes you've done on the pull request in a real live app running in a real environment. And when the pull request merges, it's going to clean this all up. And perfect. I think that's a really powerful thing. So I hope it was useful. I hope I didn't go too quick. And with that, I'm going to stop my sharing and take you to the next person. Thanks very much.
Excellent. Thanks a lot, Wouter. It was really, really cool. We use ArgoCD as well at Vision. We like it a lot. So there's a question for Wouter, but we are going to do it after all the sessions. So please stay until the end of the sessions. We have a small question, or you can answer directly on the chat. I can forward that to you on the chat. Wouter, don't worry about that. So now it's time for Steven to talk about the security aspects of APIs. So Steven, the stage is yours.
Thank you, Adrian. And what a perfect time, Wouter. That's just fantastic. And very nice to meet you all. I'm also calling in from Belgium. So 2 out of 3 speakers from Belgium. So Adrian, maybe next time you need to think about at your meetup to make sure there's some Belgian beer present. And you can be sure that you can come over as well. So let me share my screen here as well. So I'm a solution architect with a company called Noname. We're very active in the API security space. Now, the talk that I'm going to give to you today has almost nothing to do with Noname. I just want to introduce you into the wonderful world of API security. And let me click present here. I have a few slides, but just like Wouter, and it's definitely not as advanced demo as he, but I'm also gonna show you a little bit on how you can breach certain APIs. And in fact, I also put up a GitHub repo with all the instructions for you to go and deploy a lab on your laptop if you want by using Docker. And then once that lab is set up, which I already did, there are also some instructions and demonstrations on how to breach APIs. And then at the end, I'll also give you some thoughts on how to protect APIs in your day-to-day life. So why API security? And I hope that some of you on the call already realize that APIs require dedicated attention from a security point of view. As we all know, APIs are driving the majority of the communications between machines. In fact, there is a study that says that more than 80% of all the web traffic is driven by APIs. And a lot of organizations who interact with third parties, who interact with customers via mobile apps, but also internally to that backend system to communicate with each other, they're using APIs, be it a REST or SOAP API, and now you have newer types like GraphQL, gRPC, or even Kafka-based APIs, depending on the use case. And the thing is that an API is not that difficult. It's not that complex to spin up an Angular application, expose it over an HTTP endpoint, and apply an OIS, and boom, you have an API up and running. It's really not complex to create one. But with that developer velocity, because it's so damn easy, we do see a friction between development and security. And in a lot of the cases, a lot of enterprises that we met, and this might be a little bit of a surprise to you, it was at least for me, let's say 30 to 35% of all the APIs are unknown to the security operators. They are typically known to the app owners or to the developers, but as we all know, developers come and go, software get decommissioned, but maybe there are some leftovers in the environment, and that results in that 30 to 35% of the ROG APIs that are completely bypassing the security measures that the security teams put in place. And because APIs have everything to do with how do systems exchange data with each other, these APIs are now becoming an ideal attack surface for malicious users. And we can debate about the likes of Gartner, but it is important that also these companies are now stating that the API attack surface is going to be one of the most common attack vectors for enterprise web apps in the not so far away future. Now it's going on as we speak. If you Google API breach, you will find tons of examples. Also mainly driven by GDPR. Customers are now mandated to publish these type of things. At the bottom right, it's an article from Brewdog. It's a UK brewery, and as a Belgium, as soon as they start to hit breweries, you can be sure that we take it very seriously. So this happened, I think, a week ago or so, via an API security flaw. They actually opened up the data, a lot of financial data of their customers to that malicious users, to a malicious user. I'm sorry. One of the most impactful one from a financial point of view is a case at British Airways in 2019. They got first a record fine of almost 180 million pounds, but they were able to negotiate that back to 20 million pounds, which is still a very, very significant amount of money for an API breach. Luckily, the community also realized this, that APIs do require dedicated attention. Perhaps most of you are aware about the OWASP Foundation. It's a well-known security foundation, especially in the web app world. They are very, very well known for a few projects, and one of their projects is a list of top 10 security risks for web applications. It's like the industry baseline when you want to go and secure your web apps. Now, a year and a half ago, that same community published a list of top 10 risks associated with APIs, which was a huge, huge milestone, because before that, security folks were thinking that they have to treat an API just the same as how they treated a web app. But now there are new risks documented and published, and companies today are now trying to figure out how to best implement security measures to protect them against these risks. The number one issue as part of that top 10 risk is a BOLA, a broken object level authorization. In the web app world, it's also sometimes referred to as an IDOR. In essence, very easily explained, it is the possibility for a system or a user to access data that he or she is not authorized to access, even though potentially that user is authenticated into the system. An example from our day-to-day life to compare this with, let's say that I have a hotel card, an entrance card. I can open up the main entrance door, so I'm authenticated to access the hotel. Then I go to my room, I can open up my room with the same card, I'm authorized to access that door. But if I can also open up with that same card the door of my neighbor, at that point I hit a BOLA, because I'm authenticating the system, but I can access an unauthorized piece of data, in this case, the hotel room. And one of the challenges, and that's also why I'm super, super happy to have the opportunity to speak with you, is one of the challenges that I see every day is that people and security folks and app folks and app developers, they're simply not aware that they are at risk, because they might have implemented a web application firewall, API gateways, maybe some other security devices. But most of these devices, if not any of them, they can understand the business logic of the application. And that is exactly what an API does. It communicates with backend systems. And if there is a flaw in the backend system, then via that API, that flaw can be very, very easily exposed. So simply said, a web application firewall, an API gateway, service mesh, if you want to say it, they absolutely add value to every organization, but they're simply the wrong tool for the job, and the job in this case, API security. So what I want to do is, I actually want to show you how easy it is to expose something or to breach something in case a developer forgets to add something in the code, or maybe just is not aware of such a system. So on this GitHub repo, and I'll make sure that I copy paste it in the chat later on. It's a step-by-step instruction on how to set up the environment. It's based upon Docker, so you can run it on your Windows, on your Mac or whatever on the next machine. I'm using a vulnerable API application that is from an open source project, as well as Kong, which is a well-known API gateway. I have to make a disclaimer here. I love Kong. It's fantastic technology. Nothing that I'm going to demonstrate has to do with the weakness of Kong on its own. It's just a matter of Kong is not a security device. It has some security features built in to protect you from an infrastructure point of view, but it's absolutely not an API security platform. But I hope that a lot of you use Kong or any other API gateway. So within that GitHub repo, there are some step-by-step instructions on how to provision everything, as well as step 2 is to deploy a vulnerable API application. And once that is up and running, you will have something like this. I'm just going to put this in here. All right, so I already did that. I was not brave enough to do everything during the demo about it, so I learned something there from you. So if everything is configured, you will get 3 Docker containers. You will have the database for Kong. You'll have a Kong gateway, and then you'll have that vulnerable app. It's all running on my local host on one network. If I connect into port 5000, I will be redirected into the app. If I connect into 8000, I will be going to Kong, and so on and so on. So that app is already up and running, and here I have 2 tabs open. So I have my local host port 5000 and my local host 8000, the route /v1. And what I want to point out here is if I hit refresh, I can see here with my developer tools some details of that specific request. I can see that nothing special inside the headers. I just get the response back, which you can also see on the left-hand side. Now, if I hit that same application via the Kong gateway, if I hit refresh here, what you'll see is in the headers that I'm using Kong 2.5, and I configured a few security functionalities on Kong, like rate limiting. So if I hit this like a few times, you will get an error saying that the rate limit was exceeded 429. This is very helpful in case to help you against a DDoS attack, for example. If I would do the same directly on the API, then it's not protected at all. So absolutely valuable to implement a Kong. Now, at this point in time, there is no authentication configured to that Kong route. So let me very quickly enable authentication to that specific API route. I have it somewhere here. There we go. So if you're familiar with Kong, this is just a plugin that I enable on a specific route, v1. And then I'm going to say that plugin is the authentication plugin. I'm just going to say put it to true. If I now go back in here, if I hit refresh, you'll see that I can't access the service because there's no API key provided as part of the request. Super straightforward. Now, what I'm going to do for the next part of the demo is I'm going to use a tool called Postman. Again, feel free to use the own tools that you prefer. It's just, I think it's an easy way to send out API calls and to test APIs. What I did is I have a few collections, and by the way, these collections are also posted on that GitHub repo. I have a base variable configured in that Vampy collection where I go to that route v1, and then in here I have a few API methods configured or resources configured to go and hit the service. What you can see in the header is that I actually use an API key as well, API key with a magnificent value API key. If I hit send, then I can get the result back from the service. Now, what this service is all about, it's all about storing some user data associated with books. So who borrowed which book in, for example, a library. That's what the application is all about. And in the app, I actually created a debug endpoint. Typically, that debug endpoint is something that you remove in production. Sometimes we do find out that there are still debug endpoints in production. If I hit send, you can actually see what is stored in the database from a user's point of view. So you can see that I have a username, name1, with password, pass1, name2, pass2, and so on. Do note that the admin values are set to false for these users. Okay. What I'm now going to do is I'm going to log into the system again via Postman. There is no fancy UI, so bear with me. So in the body, I actually pass name1, pass2. Let me maybe first show that it works. So name1, pass2, that specific endpoint. If I hit send, you'll see that, hey, I can't log in because the password is not correct for that user. So I'm going to say name1, pass1. Hit send. All right, now I successfully logged in, and I get a token, error token, which is commonly used in the app world. And what I'm now going to do is that I'm going to also show you the books that are associated to me. So you can see here, name1 owns title 66, name2 owns book title 0, name3 owns book title 19, and so on and so on. Now, what I'm going to do is I actually want to see my details of my book. So name1 owns book title 66. So what I'm going to do is I'm going to copy paste my better token in here. I'm going to say book, and my memory is horrible. So name1 owns book title 66. That's the one. And there's so fine. I put that in. If I hit send, there we go. So now as a name1 user, I can see the book, and I can also see the secret for that book. Why can I see that secret? It's because that's the book that is allocated to me. Now, what I'm going to show you now is that BOLA issue. If I go back to retrieve all books, if I go, for example, to book title 0, which is owned by name2, let me just copy paste that in here. Also going to go in here. If I hit send, then boom, I can also now see that secret of a book of another user. So this is something that you should not be able to see. That's a traditional BOLA, whereby the developers forgot to build in an authorization check. Now, what's something else that is pretty interesting to learn about is an unauthorized password change. So again, a little bit the same flow. I'm going to hit send, and you can see that the app is still running. Again, I can hit here send and see all the data that we previously saw with regards to username and passwords. I'm going to again log in to the system. Name1, pass1, hit send, logged in, most likely the same token. Here we go. Now what I'm going to do is I'm going to say update user's password. It's a function. In parameters, I'm going to say, hey, for example, name2. Authorization, I'm going to use a token of that name1 that I previously logged in. And I'm going to say new password. And now hit send. What you would expect is that, hey, you're trying to change the password of another user. What the hell? But I actually got nothing back, which is odd. So if I now go back to this call and I hit send, what you see is that I'm able to change the password of another user. Why is this possible? I actually have the code open here. So this is the function of the call, update password. What you actually see is that I'm only looking at the username to see if I can make the call instead of looking at the token itself. So very small mistake, but can have big implications. By the way, that VAMPI model, it's pretty powerful. I think all the OWASP API risks are built into it. And you can actually set in the app when you build it, I want it to be vulnerable or not. and then it actually goes into the code, and then here you can say if vulnerable, set this, if not, do it properly. I hope that makes sense so far. So all the details are in that GitHub repo, which I will immediately post in the chat. There we go. Cool. So in the slides, we can skip this because we already provisioned everything. And I demonstrated you that BOLA and unauthorized password change. Now, I still have, I think, 10 minutes left or so, 15 minutes left. Let me show you some, or actually share with you some tips and tricks on how to make sure that you build out the right API security measures. And again, this demo is super, super basic. There are way more complex cases that I can show you at some point in time, hopefully. But this hopefully gives you a good idea of why you need to look at an API security platform, even though remember that all these calls were routed through that CON gateway. So there are, I think, three pieces of advice that I would like to give you. And again, independent of the company that I work for, I just hope that in your organizations, you will look at these three items. Let me start with the right one. Make sure, please, that your developers have the tool sets as well as the expertise to build secure APIs as well as secure code. And some of the API security vendors, what they have is they have modules that you can execute from within a CI/CD pipeline, typically your CI pipeline, to go and execute a suite of tests that are built for API security. And then you can go and execute these tests against an open API specification file before you put the API in production. That's a whole shift left idea to enable developers to build secure code. Now, even if you have implemented a fantastic shift left culture or DevSecOps program, it is still extremely important to look at the right-hand side. Never forget what's happening on the right-hand side. And that's where posture management and runtime security comes into the picture. Every company needs to have a good process and hygiene on their APIs. Today, as part of GDPR, other compliance certs, there aren't really API requirements from a data regulation point of view. But we can be damn sure that very soon the regulators will ask you questions like how many of your APIs handle a credit card, or how many of your APIs are outbound facing and exchange an email address with other systems. Those type of questions are extremely hard to answer with, for example, an application gateway or a replication firewall. And also understand, and I believe I have a screenshot of it, understand how your APIs are accessed. In fact, let me immediately go to that slide because I do think it makes sense to bring it up now. So what you see here on your screen on the left-hand side is an API resource that is accessed or hosted on 3 EC2 instances. They're all part of a specific target group in a load balancer, and that's how you can access that API. A very good setup. Now, on the right-hand side, what you can see is that there's also an API, one EC2 instance, target group, load balancer, and they can access the API like that. However, this API also has a direct route to the internet. This is something that is very, very hard for security operators to identify. And the beauty of having an API security platform is that it can tie the infrastructure metadata to the API so that you can get insights like the one that you see here. Next up is make sure that you can detect and prevent attackers whenever things are going wrong. And again, I'll give you some examples on how you can implement that later on. What I'm a big fan of is processes and methodologies. And one of the methodologies that I really like in the API security space is the one that is called DART, the Discover, Analyze, Remediation, and Testing. And what I did here is, and again, it's not, I really want to avoid that this is all about the company that I work for. What I did is here, I actually listed some functional requirements that I believe are key for everyone who is exploring the API security market. And in that methodology, I actually list these functional requirements. And based upon your organization, you will most likely give higher priorities to some of these functional requirements, or maybe you had some specific ones for you. To me, what is key as part of the discovery process is to identify every API, every single API, independent of the API type, independently that API is hosted on the gateway or not. Every API needs to be discovered in a non-disruptive manner. APIs and applications tends to be sensitive to latency, and you don't want to add any risks to it. So make sure that you have a non-disruptive, very lightweight deployment to tap into sources to identify APIs. Because APIs have everything to do with data, also make sure that you can identify data types that are consumed by these individual APIs. Like what I said, how many APIs handle a social security number? Show me all the APIs that handle a credit card. Those types of questions hopefully will be answered by you in the very near future. Make sure that you can build an always up-to-date OIS catalog, typically visualized by Swagger or with a Swagger UI. A lot of organizations have a Swagger UI or an API catalog as part of their build and design phase, but they don't really have the same type of insights in their open API specification files than on the right-hand side on production. And there are so many differences between what we can detect on the network versus how people think that their APIs are designed. And then what it ends up with is that third-party people who are using your APIs, they will call you and they say, hey, I'm calling this schema with these parameters, but it's not working, it's broken. And in a lot of cases, yeah, our documentation is out of date. So what the cool thing is about with an API security platform is that it can build these OIS and these schemas based upon real-time packets. I have some screenshots about how that can look like. These are not screenshots of the Noname Security platform, but again, leave it all open for you to identify the right partner. So on the left-hand side top, it's a Swagger file based upon open API specification files that we collect on the network. Easy to understand dashboards as well as change tracking for all the APIs in the organization, as well as then the infrastructure to API mapping that I've already explained. Next up is analysis. How are your APIs being accessed? Make sure that the solution understands the full context and the business logic of an API. And it's only when you understand the business logic and the context that that solution can protect you from things like Ebola or an unauthorized password change, which I showed you earlier on. Make sure that the solution at least supports all the OWASP API top 10 risks. Some vendors claim that they have it, but then if you start to drill down the solution, unfortunately they don't, so that's a bit of a shame. And then make sure that it's not a rule-based or a rule-based detection system, like a web application firewall, but for an API, you really need machine learning that comes into picture. I'm a big fan of unsupervised machine learning. It has some downsides, unsupervised ML, because it needs some time to learn what is right behavior in your environment, but the amount of false positives will be extremely low versus some other supervised machine learning models, because it's not really tailored to the environment of the customer itself. Again, some screenshots of how that can look like. I'm gonna quickly skip that because we're not in a sales call. Next up in that DART methodology is remediation. I like to see API security as a brain. You have your discovery and analysis, which is on the left-hand side, and the remediation is the other side. And in a large organization, these two parts operate completely separately. security find issues, and then they throw it over the fence to development, to the app teams, go and fix it. What I'm a big fan of is to integrate a security platform into the overall processes so that when something gets found, that it's machined what needs to be done. For example, automatically create tickets in ServiceNow or Jira. That's very manual still, but create a ticket. But maybe you can also integrate with devices like a firewall or an API gateway to immediately close the loop. We detected something or security detect something, push a button, and automatically remediation will take place. That's one thing that I like about remediation services. And the other thing is continuous reporting. Make sure that you always have a snapshot of how your APIs and your environments, how they are doing from a security point of view. And again, I have some screenshots on top left-hand side. It's an entry from Splunk. A lot of organizations, they have Splunk or another SIEM like a QRadar that collects all the data of the different security devices. I think it's a no-brainer that an API security platform also pushes messages in these type of solutions. And then testing, this is something that I think is so important in combination with a right-hand side understanding of what's going on in the production, also enable developers to build secure code. I do think that I have some screenshots of now our solution, but again, leave it up to you. So what we do with our solution, it's called active testing, is we have a bunch of tests, I believe 40 or 50 tests that are tied to API security. And these test suites can be customized. You can create your own tests, and then they can be executed either manually or on a scheduled basis, or you can also integrate them with a variety of tools that you see on the right-hand side to automate that entire process. And then based upon the results, take action A, B, or C. So it's pretty powerful. And I think it's a combination of the two. You need to make sure that you write secure code, but even if all these tests go well, it is absolutely possible that still there is a malicious attempt in your production that you want to be aware of. So therefore, you also need that in runtime visibility that I talked to you about. All right, that was a little bit what I wanted to share with you. Any questions or comments, do feel free to use the chat box. I hope it was a bit of interest to the audience.
Thanks a lot, Steven. Indeed, we still have a little bit of time, so I don't know if somebody has some questions for Steven regarding the subject of API security. A hot topic in Switzerland lately because we've got quite a few incidents these days at government level. In particular, it's getting very rough. Lots of attacks these days. So I'm pretty sure that somebody in Switzerland is appreciating your talk under a different light. I don't see much activity right now. So I suggest we move directly to Simone. And if there are any questions, of course, please stay until the end of the session of today. We are going to have a little time for talks and questions and answers. But in the meantime, Simone, the stage is yours to talk about the AWS load balancer.
Thank you very much, Adrian. So I will share my screen. So share screen, desktop one. Here we go. So I'm gonna enter in full screen mode. Just a health check. Can you see my screen?
Absolutely, very well.
Perfect. Great. So thank you again, everyone, for joining us today. We have a session now on the AWS Load Balancer Controller. Quickly about myself. So I'm Simone Pomata, and I'm a solution architect at AWS. I've been at AWS for more than 2 years now. And in my role, I basically help customers here in Switzerland being successful with our services. So architecting solutions that are highly available, secure, performant, and so on. You can see my contacts here in case you need to reach out. And yeah, we can get started. So we have this agenda for today. We will quickly introduce Kubernetes services. So this is really a refresher, I guess, for most of you, since this is a very basic concept. So I will go quite quick on that. And then we will talk about the ingress and green ingress controllers on Kubernetes. We will take a look at a couple of ingress controllers that are available. And in particular, we will focus on the AWS load balancer controller, which is point 3 of the presentation, where we will do an introduction about it. We will see a bit the syntax, the use cases, the architecture. And then on point 4, we will move to the advanced features of this controller, like advanced routing, web application firewalling, and so on. And then half of this kind of session will be dedicated to the demo, which is point 5. So with this, we can get started. So the first slide here is about services in Kubernetes. So why do we need services? So the basic concept in Kubernetes is a pod, which is basically one or more containers being the, let's say, elementary unit of any application. Now, the point with pods is that pods are ephemeral in nature, so they can come and they can go away. And usually they are part of a deployment, which is a replicated set of pods with other features. And usually you need, you use a service to expose those pods. And a service is an abstraction in Kubernetes, and it can be an IP address on the cluster, or it can be a port on the nodes, or it can even be a load balancer on a cloud provider that is used to expose your pods. And here we can see a bit a diagram of it. So you have a service being a single entry point, and then this service will load balance traffic to your pods. And you can use services to expose pods to the internet, like we see here in this image here, or you can even use services to expose pods internally. For example, for other pods to reach out to other pods in the cluster. And here a bit about the syntax. You are probably all very familiar with this. You have the syntax for a deployment where you define, in this case, a couple of replicas for a container which runs nginx image. And then on the other side, you have another YAML file for the service. And this service will expose on a cluster IP using port 80 the pods that you have in the deployment. And you basically use labels to associate a service with a deployment, so that all the pods that have that label get exposed by that service. Now, one service which is particularly important for today's session, because it is kind of a foundation, a requirement for the ingress controller that we will look at, is the node port service. So the node port service allows you to define, to reserve a port on all the nodes in the cluster. And basically that port will be an entry point that will forward traffic to the pods in the deployment that you are exposing. So in this case, we have port 30,001 in both nodes, and this port will basically send traffic to the service that in turn will be an abstraction to reach the pods. You have other types of services we mentioned before, the load balancer type, where basically other than a node port, a load balancer is also provisioned on a cloud provider. But the service has also some limitations. So you cannot do L7 routing, for example, path-based routing or host-based routing, or if you have many services, and each service is a load balancer, then you could have a proliferation of load balancers in your cluster, meaning that the cost, but also the, let's say, the management effort will go higher and higher. So quite sooner or later, you will notice those limitations as a company, as a developer. And so what comes here for most companies is the ingress. So the ingress is a resource, is a layer 7 resource in Kubernetes that allows you to define a single ingress, like we see in the image here, and use the same ingress for multiple services. So you have a single entry point that usually deploys a load balancer on a cloud provider, and then these ingress will be able to route traffic to different services, for example, based on the path, or to do TLS termination, and many other things that we will see later on. Actually, you need to have an ingress controller in your cluster in order to satisfy an ingress. Otherwise, creating an ingress without the controller won't have any effect. And there are a number of controllers that are available in Kubernetes, and two of them are the Nginx ingress controller that we will quickly look at, and in particular the AWS load balancer controller, which is the focus of this session. So quickly about the YAML file for an ingress. So the YAML file is the following. So you have you have kind ingress, you have some metadata, and then you have the specs section where you have rules. And as you see here, rules are a collection, so you can have multiple rules. For example, one rule per host. So this way you can do host-based routing. And then you have paths within the rules. And again, paths are a collection, and you can have multiple paths, for example, to do path-based routing. And in this case, we just have a single path that sends traffic to the test service on port 80. But you can go very sophisticated and more complex on this. So getting a bit more into the ingress concept. So we have here one of the ingress controllers that are supported by Kubernetes, which is the Nginx ingress controller. And actually, there are many ingress controllers that you can use in your cluster, but there are 3 in particular that are supported by Kubernetes and maintained by them, that are the AWS one that we'll talk about later, the GCE, and the Nginx one, which is the one that you see in this slide. So the Nginx ingress controller basically deploys the following resources. So it will deploy a load balancer on the cloud provider. In case of AWS, it will be an Elastic load balancer. And then it will also deploy in your cluster an Nginx service. And then there will be a pod in that behind that service with an Nginx reverse proxy and load balancer that will do things like layer 7 routing and as a set of load, and ultimately it will send traffic to your services. And this is a bit the architecture, as you can see here. Now, another controller that you can use, and that is the focus of today, is the AWS load balancer controller. So this controller here is basically, as you can see in this image, a bit different compared to the Nginx one. So it uses a different architecture, with the controller being out of band and with the load balancer only being part of the network path. So to be more specific, you have the ingress controller, which is basically a deployment with a couple of pods for high availability. And this controller will listen for ingress resources, and then it will create, or it will change resources on AWS, specifically the load balancer or other resources. And then it will add those L7 routing rules, it will add targets and so on to the load balancer. And then when the client connects, it connects directly to the load balancer, and in turn, the load balancer will go directly to the node port, or even to the pod IP without using a node port, as we will see later. And you can use this controller to deploy application load balancers. Application load balancers are basically layer 7 load balancers on AWS, so they can be used as an ingress resource. And then you can also use these controller to deploy network load balancers on AWS. And network load balancers are basically L4 load balancers for TCP and UDP. So these slides here shows the same architecture as before, but a bit more detailed. And we have an example here with a cluster, with a Kubernetes cluster on the bottom and AWS resources here on the top. And in the cluster, we have 3 nodes. We have 3 deployments: the green one, the magenta one, and the blue one. Then you have an API server, and then you have the load balancer controller already installed. Now, the way it works, the way it handled ingress creation is the following. So when an ingress is created, this controller will watch for changes from the API server. And then when a change comes, like a new ingress is created, the ingress controller will create AWS resources. So it will create a load balancer, and then it will create target groups. Target groups in AWS are basically the backends of a load balancer, and you can have multiple target groups for one load balancer. This is particularly useful when you have content-based routing. Then listeners will be created as well. So a listener is basically the entry point, the entry port for the load balancer. It can be HTTP, HTTPS, or any other port. And then rules are created as well. And rules are the way that you connect a request coming in with a backend. And this connection is based on rules and conditions, as we would see, such as the path, headers, host, methods, and so on. And what we can also see from this image is that the load balancer will send traffic to the node ports. And then traffic will flow from the node ports to the pods. And this is what happens on the green and on the purple, the deployments here, so on the A and B. But you can also see here that we have a blue deployment, some blue pods here with a blue target group, and we have IP mode here. So IP mode is a configuration on the load balancer controller that allows you to have the load balancer to send traffic directly to the pods. So this way, you don't have to expose a node port. You can create something like a headless service or just cluster IP or something. You don't need a node port, and then the load balancer itself will take care of sending the traffic to the IPs of the pods directly. Now, you may wonder how it works, and the way it works is that you need a CNI, a container network interface, that supports direct assignment of IP addresses to pods. And this is something that you have by default on the AWS managed service for Kubernetes, which is Elastic Kubernetes service. That with that service, your cluster comes already with the VPC CNI for AWS. If not, you need a CNI that will support this feature in order to enable the IP mode. Otherwise, you can use the standard instance mode, and that's the mode that you get by default. And you can change the mode by using an annotation, as we will see later. Now, the IP mode can be helpful in terms of slightly better latency. Of course, you have a hop less in the traffic path, but also we have on AWS and other cloud providers also provide such features where basically you have the possibility to deploy pods in a serverless way. And in AWS as such, a thing is called the Fargate. And this is a way where you simply define the Kubernetes YAML files, you deploy them, but you don't have to create worker nodes. So the resources will be deployed on serverless compute capacity. They will get the resources request that you define, but you don't have to create virtual machines. And so in this simplified scenario, you don't have node ports because you don't have virtual machines. And so the way it works for traffic forwarding is through the IP mode. So that's something which is required if you go with such a serverless deployment. Okay, so with that said, we can go a bit deeper here into the syntax for this controller, the scenarios, and how you would configure it. So we can see here a sample ingress syntax for the load balancer controller, and it's a very simple one. So we have in the spec we have a single rule with a single path that is a wildcard path. So all the traffic is sent to my app service on port 80. Now, what you see here is that an ingress class ALB is used. And an ingress class is basically an annotation that you need to define in case you have multiple controllers, multiple ingress controllers in your cluster. Because you can have more controllers in the same cluster, like you can have Nginx and the load balancer controller. And if you have more than one, you need to specify an ingress class. Otherwise, it's not clear for Kubernetes which one to use. If you have just one, you can leave the ingress class out. So that's a very basic example. And as you see, what happens is that a load balancer is provisioned on AWS, and then a node port on the cluster instances is used as a target for the load balancer. Now we have here another example. And in this example, as you can see, we have changed the target type from instance to IP. And so as it is reflected in the image, the load balancer will send the traffic directly to the pods. We also use a group name here as an annotation. And this group name is an annotation that allows you to share AWS load balancers across multiple ingress objects. So all the ingress objects in your cluster that share the same group name will have the same load balancer. And this is quite interesting if you want to keep at minimum the number of load balancers, and so the number of and so the cost of those load balancers as well. And this is particularly useful if you have, for example, multiple namespaces, but you want to share a load balancer across namespaces, or just the different ingress objects in the same namespace. And finally, here we can also see how to deploy a network load balancer. Again, the network load balancer is a layer 4 load balancer. You mainly use it for TCP and UDP, while the application load balancer that is also used very often is for layer 7, so HTTP and HTTPS. And using one or the other is simply a matter of changing here, specifying here a load balancer type in the annotation and having NLB IP, which will instruct the controller to create a network load balancer. Now, as you see here, the kind with a network load balancer, the kind is service. While if we go back to the example with the application load balancer, which is at layer 7, the kind is ingress. And the reason is why is that here you can define paths and everything, while here on the network load balancer, we are at layer 4, so you cannot define the ingress properties. Therefore, you simply expose your services with a service type. And the type of service is load balancer. And then here you can say use a network load balancer. Okay, so that's it about the basic syntax. Now we can take a look at some more advanced features in the next 5 minutes, and then we can go through to do a demo about this controller. So one of the advanced features that I would like to have a look at is traffic routing. So here we can see a basic ingress resource with basic routing. So we have kind ingress, we have the metadata with the annotations. It's an application load balancer, and it will use an internet-facing load balancer, because you can have internal load balancers as well with private IPs only, or you can have internet-facing ones with public IPs. And then in the spec, we have a single rule with a single domain, example.com, and then routing is done based on the path. So we have, for example, part 1, which is sent to service 1 as a backend, and then part 2, which is sent to service 2. So this is a very basic way to route traffic, but many customers came to us asking for more advanced ways to route traffic. For example, based on headers, based on the HTTP method, based on the source IP, and many others. So to do that, we so that advanced routing is not supported by default in the ingress resources in Kubernetes, because as you see, you just have host and path, and that's it. So we basically implemented it using annotations. And in annotations, you can define conditions, like conditions for service 1 is that the HTTP request method should be get or head. So this is a way to add method-based routing. But you can also add other ways of routing traffic, like based on the header. So you can say the specific header name should have value 1 or value 2 in order for traffic to be routed to service 2. And this can be particularly useful if you have maybe a test and the prod environment, and in the test environment, you simply add header on the request like test equal to. Or what is also supported is that you can route by query string, and this is also more, let's say, useful. So you can add a query string again, like environment equal test, and then you can define a rule here, such as when environment is equal test in the query string, then forward to service A, otherwise forward to service B. And here you can see all the valid conditions that you can use, like host header, request method, path pattern, source IP, HTTP header, and query string. So you can use all of them in combination, and you can also build some complex routing based on those. So the example here is quite basic, but you can be more creative based on your needs. Another feature that you get from this load balancer controller is SSL offloading. And not only SSL offloading, but also you have, let's say, management of your SSL certificates. So this is done through AWS Certificate Manager, which is a service that takes care for you of provisioning or importing and renewing TLS and SSL certificates. And this is also free for public certificates, so you don't pay a cent for that. And it takes care of all those things. And it also integrates with the load balancer controller. Basically, you have 3 options for importing certificates on the controller. The first option is through the host. So the controller will look at the host that you define in the spec, and then it will search in Certificate Manager for some certificate for that host. Or the same can be done by providing TLS hosts as part of spec. So it's basically called certificate auto discovery. You can enable this feature. So this is enabled by default, but you can disable it if you want. And if you disable it, you provide the certificates, let's say, in an imperative way by providing an annotation. And in that annotation, you provide the certificate ARN, which is basically an ID for the certificate that basically the controller will use to find the certificate in Certificate Manager and deploy it on the load balancer. And then all the SSL is taken care of by the AWS load balancer. And another integration that you have is with WAF, Web Application Firewall. So this is basically a fully managed perimeter firewall where you have managed rules provided by AWS or by partners of AWS, and those rules protect you from some standard threats like OWASP top 10 threats, as was mentioned in the previous session. For example, SQL injection, cross-site scripting, and so on. Or you can also create your own rules. So you have a rule engine where you can basically inspect any part of the request, such as the body, header, and so on. and you can allow, block, or inspect traffic based on any rule that you define. And the setup is quite frictionless, so you can do this from a visual console. You can create your access control list, and then you have your access control list, and you can define that in the annotation of your controller, of your load balancer controller. And then that access control list will be automatically deployed on the load balancer, so that you can, let's say, after you have defined the control list, you can use it from the YAML files in Kubernetes without leaving the, let's say, the Kubernetes interface. And yeah, to end the presentation here, we can see that today we just covered on 3 features of this controller. So traffic routing, SSL, and integration with the web application firewall. But there are many other features that we didn't cover today, such as access control, so defining network access rules, authentication, for example, authentication or using OpenID Connect, that can be as well handled by the load balancer, health checks that are enabled by default, but you can customize resource tagging that you can use to tag resources to make sure you know the owners. Custom actions, that's also quite interesting. So instead of just forwarding traffic to the backend, to pods, you can also return fixed responses or redirect to another URL. And this is also all handled by the load balancer in a fully managed way, and DDoS protection as well that you can enable. And all those features are again defined from the ingress resource. You define them as annotations. You never have to leave the Kubernetes interface. You never have to go out of your Kubernetes YAML files. You define everything from there, and then the resources on AWS get configured by the controller. So you don't have to really touch the console unless you want to. So that's it. Now it's demo time. We have 20 minutes. So let's stop this presentation and let's move to the console. So here we go. So this is an environment that I set up with a terminal, with a file editor. And this environment, just real quick, is based on AWS Cloud 9. This is an integrated development environment in the cloud. I use it very often because using this, you can have your terminal here, and you can run things like, I don't know, create a cluster, close your laptop, and it will continue to execute because it's running in the cloud. Or you can even log from this laptop and maybe tomorrow from another one, and it will work. And yeah, we will do everything from here. I already have a cluster here. I will quickly do a get node here to see we have a cluster with 3 worker nodes. And what we're going to do is that we will install the controller to show how the installation works, and then we will deploy some services, and we will expose them through the controller. So let's get started. The first thing that we are going to do is the installation of the controller. And to do that, I'm going to the documentation for the controller and follow the steps. So the first step here is to create an identity provider. And this provider is needed because the controller needs permissions to change AWS resources, such as create a load balancer. And so we need to create an identity provider for the pod to assume that role. So here we go. We need to define the region. In this case, it's Ireland, and also the cluster name. For knowing the cluster name, I need to go here to Kubernetes service because I don't remember the name of my cluster. I can also do it via CLI, but yeah, this is quite simple this way. So here we go. So this is the command that I need to execute to create the identity provider, and here we are. So once we have the identity provider done, we need to create a policy. A policy is basically the language that you use in in IAM, in AWS IAM, to define what the controller can do. So you define that the controller can create load balancers, describe the instances, and so on in order to operate. So this is the policy. I simply curl the policy, and then I create a policy out of this YAML file. Yes, I copy paste this command as it is, and then I create my policy. Perfect. My policy is here. I copy the ARN, the ID, so I have it for later. And now that I have my policy, I just need to create a service account. And this service account here, this IAM service account, will create a service account in Kubernetes for my controller. And it will also allow this service account to assume a role in AWS in order to create the load balancer or change any other resource. So it's done by this EKS control command line, and it will also use behind the scenes the Kubernetes service accounts. So I will copy this command here, and I'm gonna change this. I need to provide here the cluster name. I will copy it again from here. So cluster name is the following, and then I need to provide the policy ID that I can copy from here and paste here. So here we go. So I create my service account with this command. I copy it and I paste it to the terminal. So let's create it. And behind the scenes, it will also create some resource in AWS. It will create a role. And this is done through infrastructure as code, through CloudFormation to be specific. So it will take 30 seconds, 1 minute, and then we will have our, let's say, our service account ready to assume a role in AWS. So all of those steps, just to make sure, are one-off steps. So you execute them once, and then basically you can use the controller in your cluster. So these are only needed during the installation phase. Okay, so this part is ready. So we can continue to actually install the actual controller. So to do that, we do it through Helm. So I set a repo here for the controller, and then I apply these here. I will install the controller using Helm through this command here. So I will simply execute this command. I just need to change the cluster name. Okay, and everything else stays as it is. And so this command will use Helm to install the controller in my cluster. So let's do this, and I hope everything will work as expected. Perfect. I get this response. The load balancer is installed. The load balancer controller is installed. So we are ready to actually proceed. Great. So we can actually, now we have a cluster with a controller configured. And what we can do now is that we can deploy a couple of services, and then we can expose them. So I will do that. First, we will create, maybe I will zoom in a bit. So I will first create an Nginx deployment with 3 replicas. And then I will also create another deployment of an echo server using, again, 3 replicas, so that we will expose later those deployments. So we have 2 deployments, and then I will also expose them using a traditional node port. So I will expose the Nginx one using a node port on port 80. And then I will also expose the echo server, which is the other deployment. So 2 deployments, both exposed on port 80 and on a node port as well. So if I do get all, I will see that I have my 6 pods. I have 2 services here, Echo Server and Nginx. I have the 2 deployments, and that's what I expect. So now comes the let's say the most interesting part related to the controller, to the ingress resource, and this is where we will actually create the ingress resources to expose those deployments. So to do that, I will start from this sample code, and this is a very basic syntax from the documentation for an ingress resource. So I will go here. I will create a new file. I will save this file. I will call it nginx.yaml, and this is where I create the ingress for my nginx. So this is an ingress. I name it nginx. I will use the default namespace. This will be on ALB. This is internet facing. There are a couple of tags here. I can remove them. We don't need them. And then we just have a single rule. And this rule will we'll use a host that we can also remove because we don't have a host. And then we have for path, for the base path, we want to send traffic to Nginx. So all traffic to the base path will be sent to Nginx. We also want to make sure that this controller will send the traffic to the node port. So I will go to the documentation of the load balancer controller, and I will add that annotation. So the annotation that I need is the target type, and I want the target type to be instance, so that traffic is sent to the node port and then from there to the pods. So target type here will be instance. And I also want to, let's say, share one single load balancer for multiple ingresses. So I need to define a group name. So again, I go on the documentation here and I search for group.name. And I add this annotation as well, and I give it a value like my load balancer. So all the ingresses that share this annotation will have the same AWS load balancer. I save this file, and I think we are ready to apply this. So I will do a kube control, apply nginx.yaml. And it worked as expected. I got a warning because it's I'm using the deprecated API, but it still works. And the ingress is created. I can do kube control get ingress. And here, as you see, I already have an address, which is a load balancer created on the cloud provider, meaning that it's working as expected. So if I go on the AWS console to verify that, we will see that we have a load balancer created. So I go here, I go to load balancers. And if I scroll down here, I have my load balancers. And here we go. So we have a load balancer in provisioning state that was created by the controller. We don't need to go through the AWS console, but I'm just doing that to show that a resource was created. And yeah, that's basically it. We have this, and then we also have a listener on port 80. And if I click on view edit rules, here I can see the rules. So I just have a rule that basically if path is equal / it will send the traffic to Nginx, otherwise return 404. Now we want to do some path-based routing. So
Simone,
yeah.
We are reaching the end of your session. I'm
Yes.
sorry, time's running out. So maybe if you could probably wrap up your session.
Sure. Do I have time until 6:05 or?
Basically, yes, but you started a little bit earlier as well, and I would like to give some time for a question and answer session before people go back to their normal lives. So
sure. Perfect. Yeah, I will just deploy an additional path, and then we are done. So it will be another minute if I have it. So I will just create another here, another ingress resource. I will call it echo.yaml, and it will be a resource called echo server. It will be sending traffic to the IP, and I can say if the path is echo, send traffic to the echo server. Very easy. And I just do kubectl apply file echo.yaml, and it should work. So it says created, and just to finish, I go back to the console here with my rules. I refresh, and as you see, another rule was created with echo as a path that will send traffic to another target. So yeah, this is real quick. I had a couple of things more to show, but I think it's more than enough to see how it works. So yeah, that's mainly it. Thank you.
Absolutely.
And back
Thanks
to you, Adrian.
Thanks a lot, Simone. It was really, really interesting. So I don't know if there are any questions from the attendees. Just to go back to a question from Ankur to Wouter at the very beginning of this session. There was a question about, is there an automated way to onboard projects? So regarding ArgoCD, right? Is there an automated way to onboard projects? Typically, an enterprise has plenty of existing apps. So Wouter, maybe you have an answer for that?
Yes. So basically, ArgoCD will discover any existing resources based on the name that they have. So if you create an application and you point it at some manifests that you previously deployed without ArgoCD, ArgoCD will notice that these resources exist, and will just show them as created. So basically, because the way it works is that it takes a diff from the desired state to the actual state. And so it will look at your cluster, see that the desired state is already, that your actual state already matches a desired state, and it will say, look, I've got nothing to do, but I know these resources exist now. I had this as a part of my demo. If I have 30 seconds of time, I can actually show you, I can make ArgoCD aware of all the stuff that I created using kubectl. So is that okay if I quickly show it, or do you just want to go on to the next question?
Yeah, maybe we don't have that much time, but but it's okay. But I think I don't know if Ankur, if you're still there. I see you still on the list of participants. If you are still there, and if Wouter has answered your question, please let us know. There was also, there we go. So yes, he says yes. So you basically answered his question. That's really cool.
Right.
There was another question by Vlad who had to leave on the chat. So I just wanted to put it on record, which was basically, why would I use ArgoCD over GitLab or GitHub or Travis or whatever? And I quote your answer, Wouter, which is, I don't believe this is an either or question. ArgoCD can't run your tests, so you will be using CI systems for that. As far as the deploying goes, your CI system is typically imperative, so you will go through a script, and if it fails halfway through, you're in an undefined state. So you have to take a lot of care to write them idempotent. But ArgoCD is declarative. You ask for a certain state, and Argo will figure out the diff and apply the necessary changes, so you can theoretically start from any state and arrive where you need to be. With the self-heal feature, ArgoCD can also ensure that the state remains the one you want, even if someone modifies the cluster behind your back. Anything else to add regarding that? I think the answer was perfect.
No, that's really it. That's why you would use Argo for deployment over your CI system, but it definitely doesn't replace your CI system. You will be using GitHub Actions or GitLab or whatever you're using for a whole lot of other things.
Right.
So
there's another question from Ankur right now.
Yeah.
So it says, what value Exoscale adds on top of ArgoCD?
So essentially, what Exoscale is an infrastructure provider. So we essentially play below ArgoCD. We don't really add anything on top there. Mainly, like I said, just like AWS, so we have a managed Kubernetes offering, so that allows you to get to a cluster really, really quick. And then ArgoCD is just a very effective way of managing that cluster. And then similarly to AWS, we also have a load balancer offering, so which facilitates like getting access to your cluster, things like that. But so we're not software as a, well, we have some software as a service, but essentially like Exoscale's role is below ArgoCD and not above. So I've just been using ArgoCD as a good example of how you can get a functional production-ready deployment platform really quickly, building on top of the managed service that we offer.
Excellent. So I don't know if there are any other questions from our attendees. I think it was a great session anyway. I just wanted to take the opportunity to do a very quick advertising for something that might be interesting for our audience tonight, and actually has to do with Exoscale as well. We are together with Exoscale and Parity QC, which is a quantum architecture company. We are organizing a webinar about how to apply quantum computing principles on your cloud deployments. And there will be a free webinar that you can attend on Wednesday, November the 10th. So you can sign up for free directly on the URL that I'm going to post on the chat right away, which is for everyone. And there it goes. So if you're interested, I strongly recommend that you attend this presentation. I think it's going to be really, really interesting. So please sign up. And of course, the webinar will be made available afterwards for watching. So if you cannot attend that day, I strongly recommend that you watch it anyway. Good. So that was a great session. I would like to thank Steven, who unfortunately had to leave earlier, and Wouter and Simone for this incredible presentation. Thank you so much. It's been really interesting to have you here. Stay tuned for the February meetups. So if you would like to present, please let us know. We would be super glad to have you on stage, and hopefully it will be in person. So I'm looking forward to see you all. So for me, this is the last of these CNC meetups for 2021. So I wish you a great end of the year. Stay tuned for more content and see you soon. Bye-bye.